Hi students, this lesson is on Introduction to Functions. So what exactly are functions? Functions are where you'll see an input and an output table taking place. So a function is a rule that establishes a relationship between two quantities. You have, and we'll see, input and output tables. For each input, there is an output. So as you can see here on our examples, we have our input and output tables. Input is the value going in, output is the number coming out here. So what you'll notice with some of the terminology with functions are domain and range. Domain are all input values that represent the domain. So input would be the domain. And then the range are all the output values. So our outputs are going to be the range. And then on our chart here below too, it also input output, we have our domain input and our range is our output. So let's work on some examples here looking at functions. Example number 1, they want us to make an input-output table for the following function below, which is this, y equals 2x plus 3. And they want us to use the value of 0, 1, 2, and 3 as the domain. So let's go ahead and fill out this chart. We have our input. That again represents our domain. They gave us our domain values of 0, 1, 2, and 3. Now what we have to do is use this function here to find our output values, which is our range values. So what we're going to do to solve this is we're going to use this formula, 2x plus 3 equals y. We're going to substitute our input values, 0, 1, 2, 3, and for x to find our y, our output. So here we have 2 times 0 plus 3. 0 plus 3 is going to give me an answer of 3. Next one, 2 times 1 plus 3. 2 plus 3 gives me 5. 2 times 2 plus 3, so that's 4 plus 3 gives me 7. And last one, 2 times 3 plus 3, that is 6 plus 3, which gives me 9. So these are my output values. So what values of the table represent the range? That is going to be my output. So we'll say the range is going to equal, and I like to put them in parentheses, 3, 5, 7, and 9. And that'll be it for that answer. Example number 2, here we have a story problem, very similar to what we just did, but a word problem here. And this word problem says, as you dive deeper and deeper into the ocean, the pressure of the water on your body steadily increases. The pressure at the surface of the water is 14.7 pounds per square inch, which is PSI. The pressure increases at a rate of 0.445 PSI for each foot you descend. Represent the pressure P as a function, meaning an expression, an algebraic expression, of the depth D for every 20 feet you descend until you reach a depth of 120 feet. So we're taking everything that word problem is stating and writing an expression, an equation for the function. So the way we have to look at this is we have to look at what they're asking. They're asking for the pressure at a given depth. They're wanting us to represent the pressure P at a given depth, okay? So how do we go about doing that? We take the pressure at the surface, which is 14.7. The pressure at the surface, 14.7. We add that to the rate of the change of pressure. The rate the change of pressure is 0.445 PSI for each foot you descend. So those are values that you know and have. And then what they want us to do is take the given depths and multiply it by that. And we don't know what the depths are. That's what we're going to find. So our algebraic model, I'll write it here off to the side. is going to be the pressure at a given depth equals the pressure at the surface plus the rate of change of pressure times your diving depth. So what does that look like as a function? The equation of a function? We could say P, the pressure at a given depth, P equals, the pressure at the surface is 14.7 plus the rate, which is 0.445, times your diving depth. We don't know that. That's what we're going to find out. So now what they want us to do is they want us to create a table based on this. They want us to create an input-output table for this function to get to reach the depth of 120 feet. So what we're going to do is I have my input, which is going to be the depth on the left, and my output is going to be the pressure P. So what we're going to do is plug in values for the depth D. I would go about starting with, it says represent the pressure P as a function of the depth D for every 20 feet you descend. So we're going to start with 0 and then descend every 20 feet. So 0, 20, 40, 60, 80, 100. And then 120. Sorry, I'm running out of room here. So what we're going to do is we're going to take those depths, 0, 20, 40, 60, 80, 100, 120, and plug it into my formula to find my output. So here it's going to be 14.7 plus 0.445 times 0 to get an answer of 14.7. Okay. The next one, it's going to be 14.7 plus 0.445 times 20. Now, I will let you use a calculator when you're solving this. What you're going to do is multiply the 20 times 0.445 first and then add the 14.7 to get an answer of 23.6. For 40, we use the same function and plug in 40 for D. And we get 32.5. We'll plug in now 60 for D. And we're going to get an answer of 41.4. When we plug in 80, we're going to get an answer of 50.3. 100 is going to be 59.2. And the last one for 120, a depth of 120, we're going to get an answer of 68.1. Again, I apologize, we ran out of space there. So that's what my input-output table is going to look like for that function that we created above. So last part of this example right here is they want us to create a graph, a line graph of the function table. So we're going to take the data in the previous chart and now create a line graph based off of that. Now this graph here is what I found online. So I'm going to pretend that this is based on 10. So this is like 0, 10, 20, 30, 40, 50, 60. So we're going to graph, we'll label this graph is based off of tens. So again, I'll say 10, 20, 30, 40, 50, 60. And I think we get the idea here. So remember with our graphs, we need to label them because that's important with graphs. So the title of my graph is going to be underwater pressure. My x-axis, my domain, my input is my depth, which is in feet. My output is my y, and that is representing the pressure in PSI. So I know I don't have the table right in front of me, but I'm just going to go ahead and graph these points for you. 0 was at 14.5. So again, you're going to estimate the best you can where these points are going to go. 20 was 23.6, so 20 is 23.6. 40 is 32. 32.5. 60 is going to be 41.4. Sorry, my points are going off my graph right here. 100 is 59.2. Oops, I'm sorry. Not, I missed 80, sorry. 80 is going to be 50.3. 100 goes off the chart here a little bit, but let's keep graphing it. 100 is 59.2, which is about right there. And then last one, 120 is 68.1. So let me put in 100 and 120. We said 100 was 59.2. And then 120 is 68.1. So this is my line graph. I can connect the points best I can. Sorry, it's a little squiggly there at first, but you get the idea. And that is the line graph that represents my word problem and that function and that input-output table that we had talked about. So you're going to be doing some of this in class, and we will go through it. Thanks so much.